everybody, it's time to review for your random variables quiz. Today, we are going to be working through the random variables quiz review summary, and you'll find this towards the back of your notes packet, probably around page 53 or so, but it is somewhere there. And do I even have the page? No. So somewhere right there. There's three things we need to talk about. First of all, we'll talk about discrete random variables. We'll talk about the binomial distribution, and then we will talk about the geometric distribution. And I hope you have your formula sheets handy. If you do not, make sure you pick up a new one from me. But your formula sheet, if you look at it, here's what it looks like. Actually maybe not all, but most of the formulas you'll need for this quiz are found right here. We have formulas for the discrete random variable, the binomial distribution, and the geometric. So it's going to be up to you to know, do I need to use the discrete random variable formula, which has the mean and standard deviation? Do I need to use the binomial distribution? Is the word problem I'm looking at a binomial with the mean and the standard deviation belonging to it? Or is the situation I'm looking at more of a geometric distribution, and then I can use the mean and standard deviation formulas to find as well? I do want to point out that whenever you're asked to find the mean, that's also known as the expected value. So if you're asked to find expected value, you can use the formula for mean. We use those interchangeably, E of x. And you will need to be able to interpret means and standard deviation in terms of the context of the problem. So that means you're going to need to include the units and the context whenever you discuss the interpretations for each one you have. So let's start off by talking about, let's talk about the discrete random variable. So that's where we started off. Discrete was in notes 5. And that's where we first were introduced to a probability distribution for a discrete random variable. You might see one as a table or a histogram. And we had to do a couple of things. We had to find the mean or the expected value. And to find the expected value, we are going to use this formula. And it looks a little more intimidating than it actually is. But what you do to find the mean of a discrete random variable is you take the x value, you multiply it by the probability of that x value, and then the sum means you're going to add up all the individual probability and the values of x's. So 1 times 0.2 plus 2 times 0.25, and then do that all the way until you get to the end, 4 times 0.15. So make sure you know how to use and interpret that formula. The way that you would interpret the number, you would say in the long run, we would expect to see whatever the number is and then whatever the units are for the x. And a reminder, all of these numbers and the probability, since it's a probability distribution, they all need to add to be 1. To find the standard deviation, here is the formula for the standard deviation of a discrete random variable. It also has that sum symbol in there, but what you're going to do is you're going to take each x value. So over here I would take 0. So standard deviation x equals the square root. So I would take 0, subtract the mean. So the mean that I found from over here. Now I haven't calculated that, so I'm just going to use a placeholder, mean of x squared times the individual probability, which is 0.3. Plus, and then I'm going to move on to the next couple. 1 minus whatever I calculated that mean of x to be, square it, times 2. And you're going to do that for every single value of x and its probability until you get to the end of the table. 4 minus whatever the mean was, squared, times 0.15. Okay. Then, after we did that, we talked about combining random variables. So if I zoom in here. So combining random variables are when you're taking two distributions and you're combining them together. So let's say I had a distribution x with a p of x. Make this a little smaller. So let's say I had 0, 1, and 2. Let's say 0.3, 0.2, 0.5. So here's a distribution for x. And then a distribution for y. Probability of y. Let's say I just had 0 and 2, 0.2, 0.8. If I were to take these two distributions and combine them together through adding, the way that I would find the mean of both of those together, instead of having to find both a new distribution, I would just take each mean and add it. The expected mean from x with the expected value from y. For subtraction, you subtract the means. For standard deviation, whether you're adding or subtracting the distributions, we use this formula, which is kind of like the Pythagorean theorem, that a squared plus b squared equals c squared. And then this notation is going to show you that if you multiply or divide or add a number to a distribution, the mean gets affected by both. So mean will be affected by adding, subtracting, multiplying, and dividing. But the standard deviation is only affected by multiplication. And we should actually say this is the absolute value of b that would be multiplied by it, because we keep standard deviation positive. Then, after we talked about just a regular discrete random variable, we spent a lot of time talking about a binomial distribution versus a geometric. So for something to be a binomial distribution, these are the four specifications that have to be met. So there has to be two possible outcomes, a fixed probability of the success, independent trials, and a fixed number of trials. So what you're doing with binomial distribution is you are counting the number of successes in a set number of trials. So x would be the number of successes you want, p is the probability of success, and n is the number of trials. And so this is a lowercase x, by the way. So we had our formula for calculating a specific value of x, but you can also use binomial PDF. PDF is what you use when you want to find the probability of x equals x. We also had binomial CDF. That's what you use when you want to find the probability that x is less than or equal to x. And then there were formulas for the mean or expected value and standard deviation. For the geometric distribution, the criteria are very similar, except instead of having a set number of trials and you counting the successes, you are going to see how many trials it takes to get your first success. And that's the difference between binomial and geometric. So we had our formula for binomial distribution. We use GeoMet PDF whenever we want to find the probability that x equals x, versus GeoMet CDF when we want to find the probability that x is less than or equal to. And then we also have formulas for the mean and standard deviation. So once again, there's basically 4 ideas you're going to have on this quiz: geometric distribution, binomial distribution, And then we've got our random variables, but then you also had what happens when you add two distributions together, subtract, what happens when you add, and what happens when you multiply. So those are the 4 ideas. So if you are studying, what I would work on first is number 1, you want to make sure you know how to tell a distribution is binomial, geometric, or neither, because your formula sheet is all there, but you need to know if the situation is binomial, is it geometric, or is it just a regular discrete random variable. So good luck. Let me know if you have any questions, and I will see you guys next class.